Today we'll start a new topic which is laser. So laser is an acronym of light amplification by the stimulated emission of radiation. So it can amplify light by stimulated emission of radiation. Now what is stimulated emission of radiation? For that we'll talk about types of interactions in lasers. So there are three types. First is absorption, and in some books they write induced absorptions, sometimes stimulated absorption, but it is absorption. And emissions, there are two types of emissions, spontaneous emission and stimulated emission. So there are three types of interactions. Now in laser, we use stimulated emission. But before understanding stimulated emission, we need to understand absorption and spontaneous emission. Now, emission or absorption takes through quantum of energy, which is bundle of energy, and there is a particular term for this, which is photons. Right, so Planck has discovered that energy of photons is directly proportional to frequency. If we'll remove this sign of proportionality, we can write E is equal to h nu, where this h is Planck's constant. And there's a particular numeric value for this, which is 6.626 times 10 raised to the power minus 34 joules. So we'll have to use this value while solving numericals based on this topic. Now we'll talk about absorption first. So here we can see that there are two energy states, right? E1 and E2. And energy level increases from bottom to top. So it is clear that the energy E2 will be greater than E1. Now, if you want to find out how much is the difference in energy level between these two stages, we'll consider the bottom state as ground state and the upper state as excited state. So if you want to find out the difference in energy level between these two states, so it will be E2 minus E1 because E2 is greater than E1. Now atoms lies here initially in the ground state. Now what happens is when any photon, which means bundle of energy, incident on it, this atom will absorb this photon and it will become excited and it will jump into the excited state, which means in E2 energy level. So this much amount of energy, delta E is equal to E2 minus E1. This atom will absorb and it will reach here at the excited state. Now, because delta E is equal to E2 minus E1 and we know that E is equal to h nu. So here energy is how much? Delta E is equal to E2 minus E1. So at the place of E, we'll write E2 minus E1 is equal to h nu. So if you want to find out the frequency of this case, we'll get E2 minus E1 divided by h. So this will be the frequency of photon which has absorbed by the atom. So they can ask a numerical based on it. So you'll have to use this formula. So what is happening over here? Here the incident photon is absorbed and it is represented as atom plus photon which is incidented. So it will give us an excited atom which is here at the excited state. So this was about absorption. Now we'll see emission. So there are two types, we know that. First is spontaneous emission and second one is stimulated emission. So we'll do a comparative study between these two. So in case of spontaneous emission, we don't have to provide any photon from outside. In this case, without any outside activity, spontaneously the atom which was in excited state will come back to the ground state without providing any photon from outside. It will come back to the ground state and it will release photon. And again, the frequency of this photon we can calculate with the help of the same formula. So it will be E2 minus E1 by H. So what is happening over here? Atom which was in excited state gives us one atom and one photon. So this is the photon and we'll get atom here. Now here, in case of stimulated emission, we'll have to provide or incident one photon from outside so that the atom which is in excited state will come back into the ground state due to the incident photon we are providing from outside, and that atom which was in ground state will release the atom which it has absorbed. So the atom while coming back from excited state to ground state will release the photon which was absorbed when it has jumped from ground state to excited state. The same photon it will release. And the point to be noted that these two photons released by excited atom while coming back from excited state to ground state will be in same phase, and the speed will be same and wavelength will also be same. But here, in case of spontaneous emission, photon released by atom while coming back from excited state to ground state, this photon will not be in phase with the photon which atom has absorbed when it has jumped from ground state to excited state. So that is the difference. Now here we have one excited atom plus photon we'll have to provide, and it will give us atom plus photon plus photon. So we'll get two photons and these two will be in same phase. Now properties of laser. Laser light or laser beams are monochromatic in nature because they consist of only one light or one wavelength. Like, what is monochromatic? Like, white light is not monochromatic. White light is polychromatic because white light has 7 colors and each color will have different wavelength. So that is polychromatic, and laser light is monochromatic. Divergence and directionality. So this is another property which means that the beam is well collimated. You can see laser lights look like this in reality. So they are well collimated, we can see, and travels a long distance with very little spread. So they are not spreading like white light from sun. I'll show you the diagram. Next is coherence. It means that all the individual waves of light are moving precisely together through time and speed. Like if two light rays are moving like this with maintain the same phase difference, same wavelength, they are said to be coherent. Brightness, the radius of laser is an important factor. It is defined as power emitted per unit surface area per solid angle. So we can define brightness per unit surface area per unit solid angle. Now what is this? Because laser lights are like this. So from here you'll get a collimated beam. So if we'll draw a perpendicular, this is theta solid angle, right? And this is area, this whole thing. So per unit surface area per unit solid angle. With that, we can define brightness like this to find out the power emitted by laser. Now here we can see the difference. This is a laser device and these are the laser beams. They are well collimated. They are traveling in the same direction, coherent also, maintaining the same phase difference and same wavelength. So this is how they are showing. Now if we'll have a look on ordinary light, this is a light bulb. So light is traveling in different directions. This is unpolarized. These are unpolarized photons. These are polarized photons. And this is non-coherent light waves, or we can say incoherent. So they're crossing each other, they are not maintaining same wavelength, same frequency, same distance, right? So these are not coherent and these are coherent. So that is the difference. This was all about laser and its properties. Thank you.